A crowd presses against the greenhouse railing as a towering dark red bloom opens and pushes the smell of rot into the warm air. People laugh, wince, cover their noses, then lean closer anyway. The plant looks ceremonial, almost royal, with a flared, pleated skirt wrapped around a central spike. But the air around it suggests something entirely different. It smells like spoiled meat, damp garbage, old fish, and something animal that should have been buried. The strange part is not that the smell is strong. The strange part is that the plant is succeeding. In the thick greenhouse heat, the odor moves outward like a signal. Flies begin to investigate. Tiny bodies land on the dark surface, crawl along the folds, and search with the urgency of insects that believe they have found death. To a human nose, the bloom seems offensive. To the right insect, it is an invitation. This is the trick behind the famous corpse flower, but it is not the only plant using it. Across the world, in rainforests, deserts, forest floors, and hidden underground chambers, flowers have evolved to smell like dead animals, dung, fungus, urine, and fermenting organic matter. They are not broken flowers. They are not failed perfumes. They are advertisements aimed at a different audience. Most people learn a simple version of what flowers are for. Flowers are bright. Flowers smell sweet. Bees and butterflies visit them, collect nectar, brush against pollen, and carry that pollen to the next bloom. In that version, a flower is almost always pleasant because it is designed around sweetness, color, and reward. But pollination is not always gentle, pretty, or bee-centered. Some insects do not spend their lives looking for nectar. Blowflies, flesh flies, carrion beetles, fungus gnats, and other scavenging insects search for decay. They follow the scent of dead tissue because it can mean food. It can mean a place to mate. It can mean a place to lay eggs. Their senses are tuned to signals most humans avoid. Carrion mimic flowers exploit that search. They do not need to smell good to us. They need to smell convincing to a fly. They release chemical compounds associated with decomposition. They use dark reds, purples, browns, mottled patches, hairy textures, and leathery surfaces that resemble damaged flesh. Some even produce heat, warming themselves so the odor spreads farther and the imitation feels more alive by seeming freshly dead. The deception can be brief, but it only needs to last long enough. An insect lands, crawls, investigates, and brushes against pollen. It may leave unrewarded. It may be temporarily trapped. It may fly away, still searching for the thing it thought it had found. Then, if the plant is lucky, that same insect visits another foul-smelling bloom and completes the exchange. The result is one of the strangest patterns in botany: flowers that imitate death in order to reproduce. And the famous greenhouse corpse flower is only the doorway into a much larger story. There are giant blooms that appear from parasitic plants with no obvious leaves, star-shaped flowers that look like wounded animal skin, underground chambers that smell foul and hold beetles for a time, tropical towers that warm themselves like living vents and release their strongest odor at night. The first reaction is disgust, because the smell is doing exactly what it evolved to do. It cuts through the air and demands attention, but underneath that disgust is precision. These plants are not simply stinking. They are broadcasting. The real question is not why a flower would smell like death. The real question is how many different ways a plant can fake a corpse. The deception begins at the molecular level. A carrion mimic flower is not releasing one simple bad smell. It is mixing volatile chemicals that insects already associate with decay. Dimethyl disulfide and dimethyl trisulfide can suggest rotting flesh. Trimethylamine can add a fishy, dead animal note. Isovaleric acid brings a sweaty, rancid edge. Indole and skatole can resemble feces and animal waste. To humans, these odors collapse into one category: foul. To an insect, the blend can be specific. One mixture may call to blowflies. Another may attract fungus gnats. Another may pull in beetles that search near dung, carcasses, or fermenting matter. The flower is not just smelling like death, it is choosing which version of decay to imitate. Then some plants add heat. In the Titan arum, Amorphophallus titanum, the central spike, called the spadix, can warm during bloom. That heat helps lift odor compounds into the air and send them farther through the surrounding forest, or through a greenhouse packed with people holding their noses. The bloom is brief, often strongest on the first night, and the timing matters. The plant is not a single giant flower, but one enormous inflorescence, with many small flowers hidden near the base. Its dark red spathe opens like a wound-colored chamber, while the heated spadix broadcasts the signal. The smell says something has died. The warmth helps sell the lie. Other carrion mimics work through sight and touch. Stapeliads, including Stapelia gigantea, produce enormous star-shaped flowers with flesh-colored surfaces, wrinkles, mottled patches, and hair-like structures. Some look less like petals than damaged animal tissue spread flat in the sun. Flies land and crawl across them, not always looking for nectar. Some are searching for a place to lay eggs. They investigate the flower as if it might be a carcass. In many cases, there is no meaningful reward at all. The insect has been fooled into treating a reproductive structure like rotting meat. Some plants go even further. They do not simply lure insects in. They manage where those insects go. Certain Aristolochia species form chamber-like flowers with narrow entrances and downward-pointing hairs. Small flies enter when the flower is in its receptive female phase. Inside, the insect moves through a controlled passage, brushing against the parts of the flower that need contact. If the insect is carrying pollen from another bloom, that pollen may be deposited. Later, as the flower changes phase, the hairs wilt or the structure relaxes. The trapped insect can leave, now carrying new pollen. The plant is not thinking. It is not cruel. But the structure works like a timed mechanism: scent, entrance, chamber, contact, release. Once that mechanism is clear, the famous giants become less like isolated oddities and more like dramatic examples of a larger pattern. The Titan arum and Rafflesia are both called corpse flowers, but they are radically different organisms. The Titan arum is an aroid from Sumatra, producing a huge inflorescence with hidden small flowers. Rafflesia arnoldiensis produces one of the largest individual flowers on Earth, sometimes more than a meter across. It has no visible leafy body in the ordinary sense. It lives as a parasite inside tetrastigma vines, then erupts as a fleshy, carrion-scented flower that attracts flies. The same nickname hides two separate evolutionary solutions, and some carrion mimics are stranger still. Hydnora africana spends most of its life underground, attached to host plants for nutrients. When it flowers, a fleshy structure breaks the surface, often low to the ground, where carrion insects already search. Some Hydnora species smell unpleasant and temporarily hold beetles or flies before releasing them. They barely resemble the familiar idea of a plant until the moment they bloom. This strategy has appeared again and again across unrelated families: Ericaceae, Apocynaceae, Rafflesiaceae, Aristolochiaceae, Hydnoraceae, and more. It works because flies, beetles, and gnats are everywhere, and many are excellent at finding decay. In forests, at night, near the soil, or in habitats where bees are not the only important pollinators, death can be a powerful advertisement. The smell is not an accident. It is a pollination system built around the senses of insects most people try to avoid. Return to the greenhouse, and the scene looks different now. The crowd is still there, drawn close by the enormous red structure and pushed back by the smell. The same people still laugh nervously. The same hands still cover noses. The same warm air still carries that rotten signal through the room. But the bloom is no longer just a botanical spectacle with a horrible odor. The smell is a message. The heat rising from the plant is not a strange side effect. It is a delivery system, lifting the chemical blend into the air, helping it travel, making the imitation more convincing. The dark red folds are not just dramatic color. They are part of the illusion, a visual echo of exposed flesh and decay. The flies are not accidental intruders ruining a beautiful flower. They are the intended audience arriving on cue. What seemed grotesque at first becomes precise. A sweet flower makes sense to a bee. A corpse-scented flower makes sense to a fly. Both are using the same basic bargain of pollination, but they speak in different sensory languages. One offers brightness, nectar, and familiar floral perfume. The other offers rot, warmth, darkness, and the possibility of carrion. One fits the human idea of beauty more easily. The other reveals how narrow that idea can be. A flower does not have to please humans to be successful. It only has to reach the animal that moves its pollen. That is why the carrion mimic family feels so unsettling. These plants expose a version of nature that is not soft or ornamental. It is strategic. It is opportunistic. It uses hunger, instinct, mistake, and timing. A fly searching for a carcass can become a courier. A beetle entering a foul chamber can become part of a reproductive mechanism. A gnat drawn to fungus-like decay can carry pollen between flowers that never smelled sweet at all. There is no moral drama in it. The plant is not evil. The insect is not foolish. Evolution has simply shaped one organism around the habits of another, and the result is stranger than invention. A parasitic flower can live hidden inside a vine and emerge only as a giant, fleshy bloom. A desert stapeliad can spread a star-shaped imitation of wounded tissue across the ground. A subterranean plant can push up a chamber that smells unpleasant enough to summon beetles. An aroid can warm itself at night and send out a pulse of decay so strong that people line up to experience it from behind a railing. The first instinct is to call these flowers freaks, but they are not botanical mistakes. They are solutions. Again and again, unrelated plants arrived at the same answer. If certain insects search the world by following death, then death can be imitated. Not perfectly for human judgment, but convincingly enough for a fly in motion, a beetle near the soil, or a gnat moving through humid forest air. That repetition is the awe beneath the disgust. The corpse flower is famous because it is enormous, rare, and theatrical. But it is only one expression of a wider pattern. The garden and the forest floor contain pollination stories that do not fit the sweet version of flowers. They are darker, lower to the ground, sometimes hidden, sometimes brief, and often aimed at creatures most people ignore. So when the greenhouse fills with that heavy odor again, the smell can be understood as more than a challenge to the nose. It is chemistry shaped by selection. It is heat turned into broadcast. It is color, texture, timing, and insect behavior woven into one event. The bloom is not pretending for us. It is performing for the flies. And for a short time, inside that warm, rotten air, a flower becomes a convincing piece of death so that life can continue.